Now, let us have the difference between high strength concrete and high performance concrete. So we have to learn more about these types of concrete. So the advantages of high strength concrete are the following. First, reduce maintenance and repair. The size of structural members like beams and columns are reduced since smaller sections are enough to carry high loads. Third one, since the size of members are reduced, the cost of formworks are less. In bridge construction, the use of high-strength concrete becomes inevitable because longer spans with minimum supports can be constructed. Constructions of slabs and floors with thinner sections is made possible. For the advantages and application of high-performance concrete or HPC are the following. Reduce maintenance costs, though the initial cost of HPC is high when compared to conventional concrete. Since less maintenance is required, it results to be more economical. The service life of a structure is more since the concrete is more durable and resists abrasion and chemical attack. As a result of high strength, the size of structural members is reduced. On the account of its superior mechanical properties, HPC panelist application in various types of structure like the following: high-rise buildings, tunnels, bridges with long spans, nuclear structures, constructions at severe exposure conditions. For the mixed design procedure for high-strength concrete, the mixed design of high-strength concrete is similar to conventional concrete with minor variations because the volume of mineral admixture is calculated too. It can be done by two methods, the IS code method and ACI method. The design procedure explained below is based on ACI method. So we have the following procedure now. First, we have to determine the mean design strength based on the required compressive strength or required concrete strength. Determination of optimum coarse aggregate content based on nominal size of coarse aggregate required. Estimation of the water content required. Selection of water cement ratio from the table based on the field strength and maximum size of coarse aggregate. Calculation of cement content based on the water cement ratio. And providing the required adjustments in the mix based on the admixtures used. For the mix design procedure of high performance concrete, the steps involved in the mix design of high performance concrete is given below. First, based on the rheological properties and compressive strength desired, the yield strength or the yield stress and plastic velocity is determined. The dosage of high-range water reducers used to reduce the water content is determined. Usually it is 1.5% of the weight of cement. Sand content required is determined from the code as per zones of construction. Coarse aggregate content required is calculated by per cubic meter of concrete. Cement content based on the water cement ratio is calculated. Finally, correction factors are applied based on IS code 10262. High-strength concrete, as the name signifies, is concrete having compressive strength more than 40 megapascal. Nowadays, due to high technological development, it is possible to obtain concrete strengths about 150 megapascal. Thus, only strengths above 60 megapascal are recognized as high-strength concrete in recent days. Compressive strength is the most important characteristic which is considered to state whether the concrete is suitable for construction or not. The other properties like tensile and flexural strength are being tested for. Compressive strength holds prime importance in the construction industry. Hence, with higher compressive strength, the concrete becomes more desirable. High-strength concrete has found its invaluable position in the construction of the following: the high-rise buildings, bridges with long spans, and high load carrying buildings built on weak soil. Ibig sabihin, taglay nito ang tinatawag nating low bearing capacity. For the high performance concrete, it is actually a concrete having high strength, high durability, high resistance to chemical attack, and high workability. In other words, all the mechanical properties of concrete are superior in high performance concrete. Though strength has been the major concern in a concrete mix, gradually the importance of durability and workability was realized in the long run, which led to the invention of high performance concrete. American Concrete Institutes defines high performance concrete as a concrete which meets spatial performance and uniformity requirements that cannot always be achieved routinely by using only conventional materials and normal mixing, placing, and curing practices. The use of high-performance concrete has overcome many problems observed in conventional concrete like less durability, weaker transition zone, low resistance to chemical attack, and difficulty in repair and retrofitting works. That's all for today. Thank you very much, and God bless us all.